These are the answers for the exothermic and endothermic exam questions, the higher tier. So question 1, some students investigated the change in temperature as sodium hydroxide solution is added to dilute sulfuric acid. This is the method they used. Figure 1 shows the apparatus the student used. So we've got a burette here, we've got a polystyrene cup with a thermometer taking the temperature. The volume of sodium hydroxide solution is a variable, which 2 words can be used to describe this type of variable. So the answer is it's continuous, because the value could be any value, and also it's independent, because this is the volume, this is the variable that we are changing, the independent variable. So the dilute sulfuric acid has an initial temperature of 24, and we can see here that it's gone up to roughly 31.5. So remember, it's 0.5, it's not obviously at 31 or 32. So from 24 to 31.5, the temperature has gone up by 7.5 degrees. Next question, figure 3, shows the students' results. Determine the volume of sodium hydroxide solution that gives the highest temperature change. Use figure 3 to help you answer this question. So the volume which gave the highest temperature was between 25 and 26, so 25.5 and 26. I would say it was 26. You do get a bit of a range here, but I'd say it was 26. Next one, D, in figure 3, the temperature when 16 centimetres cubed of sodium hydroxide solution is added is anomalous. Suggest one error that could have been made in the method which could cause this anomalous result. Firstly, they might not have stirred it, just left the actual reaction to take place and they did not stir it, or they didn't wait long enough. For the highest temperature to be reached. So either answer gets sheer mark there. Next one, the sodium hydroxide solution in this investigation contains 80 grams per decimetre cubed. That's important. The students used 40 centimetres cubed of sodium hydroxide solution. Calculate the mass of sodium hydroxide in 40 centimetres cubed. Firstly, they've given you in decimetres cubed, so you're going to have to divide 40 by 1,000 to change the centimetre cubed into decimetre cubed. And then what we're going to need to do is times it by 80. And the answer is 3.2 grams. Next one. Exothermic reactions transfer energy to the surroundings. Draw a reaction profile for an exothermic reaction using the axes in figure 1. So these are the figure 1 axes. So this is what we're going to draw. So it's asking for an exothermic. So we're going to do this. And then what we're going to do is, this is the activation energy. It goes from the reactant line to the top of the hill. This is the reactants, this is the products, and this is the energy change. So the energy that's being lost to the surroundings or transferred to the surroundings. And that would get you your 2 marks. Next up, combustion is an exothermic reaction. So I'll calculate the overall energy change. So firstly we have this bond, this bond, this bond, this bond. So we've got obviously 4 times the CH bond, so that's 4 times 413. And then we've got obviously this bond here, which is 498, but obviously we've got 2 of those. So times 2, we're going to add them 2 together, and we're going to get 2, 6, 4, 8. And then that's for the reactants. On this side, we've got 1, 2 of those bonds, so 2 times 805, plus we've got 1, 2, and then 4 of those, so 4 times the 464, and that gets you 3, 4, 6, 6, and then you do your reactants minus your products, and we get an answer of minus 818. Yep. So that's your answer. Now, figure 2 shows the chemicals given to a student. So we've got dilute sulfuric acid, and you've got 4 different powdered metals. So the student wants to investigate the reactivity of the 4 metals. Outline a plan the student could use to investigate the relative reactivity of the 4 metals. The plan should use the fact that all 4 metals react exothermically with dilute sulfuric acid. You should name the apparatus used and comment on the safe use of the chemicals. So firstly, the safe use, you should wear safety glasses. That's 1 mark already. Next up, weigh the same mass of each metal. I'm going to say powder. It's easier that way. So weigh the same mass of each metal powder. Measure a set volume with a balance. That's naming your equipment. Actually, I'm going to change this. So measure a set volume with a measuring cylinder of sulfuric acid. Spelling of sulfuric has changed, but it don't matter. You can spell it either way with a pH if you want. Measure a set volume with a measuring cylinder of sulfuric acid and add into a measuring beaker. That's just so you can complete the reaction. Measure and record the temperature. I'm going to say with the thermometer. So measure with the thermometer the temperature of sulfuric acid, H2SO4. Then add the metal. And then obviously stir. And record the highest temperature. Because in order to investigate reactivity, you need to obviously look at the change in temperature, which obviously reacts the most. Stir and record the highest temperature. and calculate temp increase, and then finally repeat for metals X, Y, and Z. I'm going to add that in there. I'm going to say start with metal W. So you've mentioned your safety. You're going to weigh the same mass of each metal, start with metal W, measure a set volume with a measuring cylinder of sulfuric acid and add it into a measuring beaker. Measure with a thermometer the temperature of the H2SO4, add the metal W, stir and record the highest temperature, calculate the temperature increase and repeat for metals X, Y and Z, and that'll get you your 6 marks, including this for your safety. Next up, another student used displacement reactions to investigate the relative reactivity of the 4 metals. So this shows your the student results. So it's asking you to give the order of the reactivity. So firstly, metal Z, it does say here as well, give the order of the reactivity of metals, use the results in the table above to justify your answer. So you can do it either way. I think you can start with the most reactive, or to the least. Now, if we look at this, the one that reacted the most was metal W, so it reacted quite a lot with all the other solutions. So I'm going to say W was the most reactive. So it's reacting with all the reactions. There's a lot of observations, so there must have been lots of reactions. Next up, I'm going to say that the next is Y, because there was, if we look at Y, there was gas here, but with X there was a few gas, so I think it reacted more. So I'm going to say Y, and then I'm going to say X, and then I'm going to say Z. The reason why Z is the least reactive because Z didn't react with anything. So if you look there, Z didn't react at all. But we do have to justify your answer. So I'm going to say W reacts with most solutions, but Z reacted with least, or none. So W reacted with the most, and Z reacted with the least. Then I'm going to say Y reacted more with sulfuric acid than X, because that didn't react as much. There we go. Next up, the student concluded that these results could also be used to justify the order of the reactivity of copper, magnesium, hydrogen and zinc. The student is not completely correct. Use the results in the table above to explain why. So, this is what you need to say. Magnesium is the most reactive. Because it is not displaced by any metal. It's the most reactive metal. Apart from potassium, sodium and calcium. Zinc is the second most. Because it is displaced by only one metal. Copper and hydrogen cannot be placed in order of reactivity. And that's because they are both displaced by the three metals. The further experiment could be to add sulfuric acid to copper and that's because copper is less reactive than hydrogen, and also then copper would not react with sulfuric acid, which is H2SO4, to displace hydrogen. There we go. Next up, so methane burns in the rate of chemical reactions, sorry, can you see that? The rate of chemical reactions can be changed by changing the conditions. Methane burns in oxygen to produce carbon dioxide and water. The activation energy for the reaction is 2648. The reaction gives out 818, so 818. The figure below shows the reaction profile for this reaction. Complete the reaction profile. Draw an arrow to represent the activation energy and then the energy given out. So firstly, the activation energy should be like this. So this is the activation energy. And that is 2648 kilojoules per mole. And then it gives out 818 kilojoules. This is the products, where obviously now there's 818 kilojoules per mole less of energy. That is the reactants. The activation energy is here, and that would get you your 4 marks. Next up, what percentage of the activation energy? What percentage of the activation energy is the energy given out? It's 31%. Next up, calcium carbonate decomposes when it is heated. The decomposition of calcium carbonate is an endothermic reaction. So how would that be different? How would the reaction profile be different? The products would be above. The reactants. So it'd look a little bit like this, with R there and P there. So it'd be a different one. Catalysts are used in chemical reactions in industry. Give 2 properties of catalysts. For each property, explain why it makes the catalyst useful in industry. Catalysts increase the rate of reaction. So basically products will form in less time, and they lower the activation energy. And that's a good thing, because then that means you're lowering your energy requirements. And therefore, it'll cost you less money if you run a business where you're going to make products. Okay? Next up, enzymes are biological catalysts. What type of molecule is an enzyme? It's a protein. This is crossing over to biology. If enzymes are denatured, they stop working. Give 2 ways that an enzyme can be denatured. High temp, and then extreme pH. Can change the shape, and then they're denatured. An enzyme called lactase catalyzes the reaction that breaks down lactose to smaller molecules. One model used to explain how enzymes affect reactions is called the lock and key model. Use the lock and key model to explain why lactase cannot be used to speed up all chemical reactions. It's because lactase acts as the lock. Lactose is the key. Lactase has an active site which will only fit the lactose molecules. So lactase will not work with other molecules. And that gets you 3 marks. So the lactase acts as the lock, lactose is the key, lactase is an active site which will only fit the lactose molecule, so lactase will not work with other molecules. So I hope you did alright with that. If you need any help, ask your science teacher. Thanks for listening.